today, or if you're not sure when we get through these, you can send over some more stuff.
Okay. No, I think these are the only ones I wanted to work on because I was doing work, like my homework, and these were the only two that I really got confused on.
Good. Good. We'll definitely be able to work through these really relatively quickly.
Okay.
Like I said, we can work on whatever you want. So if you want to like preview an upcoming lesson or get ahead, we can absolutely do that. So
Okay.
let's go ahead and get started here. I've turned off my video.
Okay.
You are seeing my screen, so you should be seeing the question on logarithms here. So it
Yep.
says, what logarithmic function represents the data in table 2? Okay.
Yeah.
So one of the fun things about logarithm, which isn't really fun, is the notation.
Okay.
And it looks like you've kind of already selected an answer here. So let's talk about why it's correct, if it
Okay.
is correct. So you've chosen B.
Mhm.
This is log base 5 of X. Log base 5 of X. Now, the only reason I'm doing that is just because the math is awkward and confusing. It's good to kind of have the right language. The
Mhm.
base is the thing that's the subscript kind of below. The thing you're taking the log of is here. So if this is right, then everything in this table should work. So the
Mhm.
question is log base 5 of 25 equal to 2? That's what we're really asking. Apologize about that.
Okay.
So there's a couple of ways to do this, and I guess that's where I need to know a little bit more about what you're doing in the course. Did you guys talk about how to rewrite logarithms as exponentials, or are you using a calculator? Like, what are you guys doing to
Um, I was just using like a calculator on my computer to kind of help
okay?
me.
Okay. Let's do it the proper way here. 25 can be written as 5 to some power.
Mhm.
Okay. And what I mean by that is 5 to some power is equal to 25.
Mhm.
So like, for example, 5 to the power of 0 is 1, 5 to the power of 1 is 5, 5 to the power of 2 is
25.
25. Have you seen that before?
Yeah.
Okay. So we can replace 25 with 5 to the power of 2.
Mhm.
Okay.
Yep.
Now there's a property of logarithms that allows you to bring the exponent out in front. So the exponent can come out in front, log base b of x, like that. So in your problem, this 2 comes out in front. 2 times log base 5 of 5. And then there's yet another property here of logarithms, which is that if you have the log base b of the same number, it equals 1. So an example would be log base 2 of 2 is 1.
Yep.
Log base 3 of 3 is 1. So in your problem, log base 5 of 5, this part is 1. 2 times 1 is
2.
2. Right. So that's why it's the that's why it's the answer here. I mean, that's why this is correct.
Okay.
We should do it for the next one. But
Okay.
just to be fair, like I've thrown a bunch at you here in the first, 5 minutes of our lesson.
Yeah.
What if this was clear? I mean, was any of it clear? Some of it,
Yeah.
none of it?
No, it was clear.
Oh, good, good. Okay. So it needs to work for all of them. And I'm going to tell you that it does, but let's look at least one more here.
Okay.
So the question is log base 5 of 125, does that end up equaling 3? Okay. And so
Mhm.
it's the same thing as before. You have to say, well, can you write 125 as 5 to some power? And yes, you can. It's 5 to the power of 3. Okay.
Okay.
So what I mean by that is 5 times 5 times 5 is
125.
125. Okay. So there's some expectation that you know this,
Yeah.
or you can use a calculator to figure it out.
Yeah.
So now you rewrite 125 as 5 to the power of 3. You bring this 3 out in front. So it becomes 3 times log base 5 of 5.
Okay.
So that's a property. Like that's we used that in the previous problem. It's
Mhm.
log base b of x to the n becomes n times log base b of x. Basically, that exponent comes out in front.
Okay, I see now.
Okay, that's always the case. You're going to use that over and over again in this course here.
Okay.
All right, now from here, it's that other property, which is that log base b of b equals 1. So when your base is the same as the thing you're taking the log of, it equals 1. And we wrote some examples. I'll write a few more here. Log base 6 of 6 equals 1. Log base 500 of 500 equals 1. So when these two numbers are the same,
It equals 1.
it equals 1. 3 times 1 is
3.
3. Okay.
Okay.
Now, just to be clear, that there's a couple of different ways you could have done number one. Like this is not the only way based on what I have, which is very limited here. That's what I can say about number one. So
Okay.
any questions for me on that?
No, I think you cleared it up pretty
Okay.
good.
So one of the things I can do here in for future notices, I can always give you a problem like this. Like I could ask you to do one like it. We could do another one like this together. It really depends on like what you're trying to accomplish. And I guess I meant to ask that earlier because I don't remember. Are you in summer school? Are you
Yeah, I'm in
retaking
summer
the
school.
are you retaking the class
I'm retaking a semester of it.
semester of it? Okay.
Yeah.
So the goal is probably to get through it. It's probably to get like minimal effort here to get through it. I understand that. Um, do you know much about the testing in this class? How you're going to be graded?
Hmm?
Do you know you're going to be graded in this class? Is it tests? Is it proctored
It's
stuff? Is it take home?
um it's just like multiple choice homework, tests, and then I do like discussion based assignments where like I do
Okay.
like a Zoom meeting kind of and I kind of explain what I learned or I
Okay.
do a little project.
Great. Great. So I can help you with all aspects of that.
Okay.
Now let's take a look here at number 4 and see if we can work this out. Now the problem is asking you to solve 4 for the x plus 2 equal 12. Now, because it's multiple choice, like truthfully, you could just substitute the answers in until you get one that's right. Now, this one may not have been like perfect. It might have been like 11.99999 or 12.00001. But that is like, because it's multiple choice, I don't know if you've taken the SAT yet or ACT, but you can
What?
always try the answers.
Yeah.
Okay, but that's not the right way to do it, but it does work.
Yeah.
So that's where I'm asking. Like, if the goal is to get through it, keep doing that. That will work. Now, I'm going to
No.
show you. Go ahead.
Oh, I was just saying I know I feel like that'd be easier, but I want to get like a general understanding of it
Yes.
so I'm not all confused.
Right. So I'm going to show you how to work this out, but what I'm saying is like I'm not discouraging you from doing it this way.
Okay.
Like if this is easiest, do it, and then ask me for the explanation later. So here's how to solve this. Now, your first approach is you'd like to make the 12 into a 4, meaning like, can you write 12 as 4 to some power?
Uh,
And the answer is no, you can.
no. Okay.
Okay, some numbers you can though, like if this were 16, you could write it as, well, 16 is 4 squared. Okay, but
Oh,
this one you cannot. So this one um, you have to use logarithms.
okay.
And I guess my question now is, have you seen or heard of natural logarithm?
What's natural?
LN, just
Oh,
LN.
okay. Yes, I've heard of that.
Okay, so there's a property here. If you take the natural log of both sides of the equation, I don't want you to freak out and say, I've never seen this before. So I guess I'll start here. Have you seen taking the natural log of both sides of the equation?
I have, but I'm not too familiar.
Okay, so let's just follow the steps here for the moment and
Okay.
see if maybe the ends will make this sense.
Okay.
So one of the properties of logarithms, ln, is that if you have the log of x to the n, guess what? That n can come out in front again. It can become n natural log of x.
Oh, okay.
Okay, so this x plus 2, this x plus 2 here is going to come
Right.
out in front.
Yeah.
Now you have to treat it like it's in parentheses though. That's an important distinction. So it's x plus 2 in parentheses. natural log of 4 equals the natural log of 12.
Question, why do you have to put it in parentheses for it?
The whole thing is considered in parentheses. Like it's not, it could, so if you write it without the parentheses, let me show it to you that way. It gives the impression that you're only multiplying the natural log of 4 by 2, but you're actually multiplying the whole thing by
Oh,
log of
okay.
4.
Okay.
All right, now our goal here is to solve for x. And what may not be clear is that the natural log of 4 is a number and the natural log of 12 is a number. Like if you went to your calculator and you typed in ln of 4, ln of 12, you get a decimal that goes on forever, but it
Mhm,
is a number. It just
mhm.
looks odd. Like we don't like it. It's like, it's not nice and friendly, but it is. It really is. So to solve for x here, I'm just going to grab this line one more time. You have to undo. So this is all the stuff you learned in your previous courses. You have to first divide everything by the natural log of 4.
Mhm.
So on the left, these cancel. On the right, it's the natural log of 12 divided by the natural log of 4. This is it. You cannot like simplify this. You can go to a calculator though. You can go to a calculator and get a number, but you have to leave it like this. You don't want to try to manipulate it.
Okay.
Now to get x by itself, you have to subtract 2 from both sides. So x equals the natural log of 12 divided by the natural log of 4 minus 2. Now this is considered what's called like exact. You might remember that from geometry, like when you find the area of a circle and it was like 16 pi, that's
Yeah.
considered exact. But what you really want, because you look at your answers don't look anything at all like what I wrote. You want the numerical approximation. So
Okay.
you have to be able to go to your calculator to do this. Now, what kind of calculator are you allowed to use in this course?
Um, I'm allowed to use a graphing calculator.
Okay. So I just dropped in the chat a scientific calculator from Desmos. So I'm gonna show you real quick how to use this
Okay.
because I think it's a really good tool here to be able to use. So let me just quickly share that screen with you, and we'll take a look at it. So one of the things I really like about this tool is that you write it the way, or you type it in the way that it's written. So it's ln 12 ln 4 minus 2. Like you don't have to fumble around with like making it look
Ooh,
the right way because it already does look the right way. Wondering if you have parentheses in the right place. And so that's why your answer is correct. This this matches what is in the answer space there.
okay.
All right, so I'm gonna just snip this in from here, go back to the screen. If we continue to do some lessons, I'll definitely be recommending this tool a lot, as well as the graphing calculator that they have.
Okay.
Basically, I want to give you tools that are going to make your life easier when you work through this course.
That's actually a lot easier than how I was doing it. So I
Yeah,
like,
yeah, and we'll do this more often. I mean, I don't expect you to get it first time, but it's a really useful tool.
okay.
So that is why that answer is correct. Now, we've got a little bit of time left here. I normally do 25 minutes for the tryout lesson, but we did start late. So do you have anything else you would like to work on, or anything
Um, no, not really. Those were the only two that were like really confusing. But other than that, I think I'm doing okay on it. Well, not okay, but I think I'm getting it. It's just some I'm not too familiar with.
fair enough, fair enough. Let me go ahead and just stop the recording